Hi Sam, this is your feedback video for the Circular Motion 2 homework. Okay, let's have a look at question 1. So they want you to label the forces acting on the car. Okay, so you get a mark for the reaction force, you've labelled that. You get a mark for labelling the frictional force on either diagram. Okay. I see you've labelled this here centripetal force. You've got to remember the centripetal force is it's the vector sum of all of the real forces acting on the car. You know, you can think of it as the resultant force. We don't label it usually. You shouldn't label it on a free body force diagram like this. You just label the actual forces acting on the car. So I see you put friction in brackets. I would have just not written this and just labeled friction. Okay, in this diagram, well done for labeling the reaction force at an angle like this. The frictional force in this case actually acts well, it will act parallel to the surface, like this. It will act in this direction, right, such that that angle there is let me think, that is the same as theta. Yeah, that's theta. Okay, so we don't actually need this. Okay, the centripetal force, let's have a, so I'm going to give you it's 1, maybe 2 marks. I'm not sure about the second mark. Okay, but let's have a look at your answer to this bit here. What are the possible origins of the centripetal force? Okay, you've put the horizontal component of the reaction force, right? That's really good. That's really good. However, you've forgotten about friction. You've got to add the horizontal component of this frictional force, and it's the sum of the horizontal component of the reaction force and the horizontal component of the friction force. Those two things together provide the centripetal force. So I wasn't sure about this mark. This one, I'm going to give you like an extra sort of general mark for this. It's pretty good. Don't forget friction. This question here, yeah, your working here is excellent. This is all correct. You get 3 marks for that. I'm going to add the marks up at the end. Okay, so no major issues so far. Question 2. Okay, so yeah, this is good. Energy conservation. Yes. Yeah. Yeah, that's correct. And yeah, this is correct. So full marks for that. Okay, this question about the van. Okay, let's have a look. Yeah, this is good, well done. This is correct. Yeah, this answer here is outstanding. It's very, very clear. You've hit all the valid points. I mean, it's 3 marks max, but you've actually got every marking point. So you've stated R would decrease, that's good. You've explained why. You've actually calculated the speed with which the reaction force would be 0, that's correct. And you've said what the consequence would be, that the parcel would lose contact with the floor of the van. It's really good work. So this question here is a past, well, they're all past paper questions, but this was on the exam from summer 2015. Quite a tough question. Let's see how you get on. So this is correct. That's correct. This is good here, the way you've approached this. This is fine. You've basically worked out the angular frequency and then used that to find F. That's totally fine. The other way to do this is to find the velocity of the ball when the tension is 60 newtons. So basically using this version of the equation, so you find V, and then you would divide that by the circumference of the circle, and that would also give you the number of revolutions per second. But yeah, this is great. This question here, you've done a really good job on this. So basically, you start by explaining why the string can't be horizontal, and you've correctly said that since it's in vertical equilibrium, there must be an upward force that's balancing the weight force, and that upward force is the vertical component of the tension, and you've correctly stated that it's T cos theta. Okay, so well done for explaining this so well, which is equal to the weight. Good. Ball doesn't move in the vertical plane. You can use the term vertical equilibrium. No net vertical force acting on it. Good. I like this. It is an example of Newton's first law. No resultant force, no acceleration. And you've also said the horizontal component of the tension is what's providing the centripetal force. Centripetal acceleration toward the center of the circle, and then you've stated Newton's second law. It's a really good answer. It would definitely be worth at least 5 marks, maybe 6. The only thing you haven't talked about is Newton's third law, okay, but I'm going to go through that in the lesson. But yeah, I mean, overall, this is really good work, Sam. You're going to get, I don't know, 32 marks or so, at least, I would think, out of 35, 31, 32 marks. So well done, and yeah, keep up the good work.